Hi, welcome to my presentation on enhancing remote team collaboration and productivity, taking a machine learning approach. So our problem introduction here is going to be the challenges that remote teams face, like communication barriers, including time zone differences and lack of face-to-face interaction, team cohesion, so the challenges of building a strong team culture when you're physically dispersed, and productivity concerns like distractions from working at home or managing a work-life balance. And so the reason for the attractiveness of a machine learning model, the relevance we have here is that the model can use algorithms applied to email and meeting data to understand communication patterns in remote teams. And for feasibility, we can use project management tools. So in our case, we'll use Jira to generate detailed work logs, and we can use that data, as well as communication records like Outlook and Microsoft Teams, and those will be used for more real-time data. We also have our value proposition here, which is the model can incorporate algorithms that can analyze individual workloads and task completion rates and recommend a more balanced distribution of tasks. And so for our CRISP DM process analysis, we're going to break it down to communication gaps, which are challenges in creating clear and consistent communication across different time zones and teams, and the difficulty of conveying tone and context through digital communication channels. Time management is also a struggle when not in a structured office environment, and then balancing the workload within a team. And our lack of engagement is definitely a problem because it's difficult to maintain team spirit and morale in remote locations, and also ensuring that all team members feel included and valued. So for our success metrics, the outcome metrics will include team productivity measured through an increase in deliverables completed on time, and employee satisfaction gauged through surveys, and trying to really see the sense of happiness and belonging. The output metrics for communication delays, we can track the time taken to respond to internal communications, and then assess workload distribution by analyzing the balance of workload among team members. The relevant factors here are going to be communication frequency, such as quantity and quality of interactions among team members, our task completion rates, assessing the factors contributing to delayed or incomplete tasks, and employee feedback, collecting qualitative and quantitative feedback through regular surveys. And so for our solution validation here, we're going to have data collection. So we'll set up a system to gather data from communication tools like Microsoft Teams, Jira, and emails, and be able to use the message logs, email threads, and the details of communication frequency and duration. Our pattern analysis will include using natural language processing algorithms to message logs and email data to identify prevalent communication styles and recurring issues. And for improving suggestions, we'll be recommending adjustments in communication channels, possibly like shifting a discussion from email to instant messaging for quicker resolution. The validation process will utilize the initial implementation, and we'll choose a software development team, a marketing team, and a customer service team in different areas and time zones to really gauge how different cultures and teams work. For our feedback collection, we'll analyze usage data to assess how frequently different features of the model are used versus those that are not. And the performance metrics will analyze communication patterns pre and post implementation to assess improvements in communication efficiency. Iterative refinement will be able to improve the user interface based on our user feedback, make it a little bit more intuitive and a little easier to navigate. And as far as scalability, after the initial implementation, we can roll it out to larger groups of teams or even possibly divisions within the company. For our data processing decisions, we'll be using a combination of real-time and batch processing. For real-time, we'll use instant messaging analysis from Microsoft Teams and be able to provide immediate feedback on communication patterns. For batch processing, we can use larger data sets like email exchanges and project management logs and be able to input that also into the model for more clarification. The model choice here, we can use clustering algorithms to apply to communication and collaboration data and identify subgroups and cliques within teams that affect overall dynamics. Additionally, we can use regression models to predict whether current team productivity rates will meet upcoming deadlines based on historical performance data. And natural language processing can be used to perform sentiment analysis on team communication channels to gauge overall team morale and identify any underlying issues. The model issues that we might face here include training serving skew. So if we have any changes to communication tools that are being used after the model is released, the data may not be as applicable to the model, or it may change how the data is construed. We can have data drift, which over time, the way the team communicates might change based on the introduction of the model, and it may skew the original model's concept. Then we have concept drift, which that can occur when the underlying dynamics of a team change due to factors like management change or even a restructure within the organization. And latency can become an issue if we're looking for real-time analytics, but it involves very complex processing. And to mitigate the risk, we'll have monitoring and updating the model. So we'll implement a system to regularly retrain the model with updated data and refine the algorithms to adapt to new patterns in team communication. Additionally, we can ensure data privacy, so we can apply encryption to all data in transit and at rest, and make sure that we conduct periodic audits to ensure compliance with data privacy laws. We'll also be maintaining the system performance by optimizing the model and related systems to process data efficiently, reducing latency, and develop a contingency plan such as fallback or manual overrides in the case the system underperforms or experiences downtime. Thank you.